Okay, hi. So here the question says that we have to find the Maclaurin series representation to find f0 to the 10th derivative for this function right here. The function here, as you can see, is cosine of 3 root d integrated from 0 to x, where the limits are 0 and x. So here, what we first do is, we know that the cosine of x has a common Maclaurin series formula, which is when summed from n is equal to 0 to infinity, it's minus 1 to the n x to the 2n over 2n factorial. This, when expanded, would look a little something like this. 1 minus x squared by 2 factorial plus x to the 4 divided by 4 factorial minus x to the 6 divided by 6 factorial, which goes on till infinity. So similarly, we use the Maclaurin series representation of this function right here. So that would look like, so at first we'd use the function cosine of d. So that would look like 1 minus d squared by 2 factorial plus d4 by 4 factorial minus d6 by 6 factorial, which goes on to infinity. And now we know that instead of d over here, we actually have a 3 times the square root of d. So every time we see a d, we're going to replace that with 3 times the square root of d. So we get this is equal to 1 minus 3 times the square root of d whole square over 2 factorial plus 3 times the square root of d to the 4 over 4 factorial minus 3 times the square root of d to the 6 over 6 factorial, which goes on again, obviously, till infinity. So the next step in finding the solution to this is, now that we have this representation of the Maclaurin series where all the numbers are plugged in as t is equal to 3 times square root of d, we see that we actually have to integrate this from 0 to x. And then, so if we do that, we're going to have to take every number and integrate it from 0 to x. So this is actually 0 to x right here, which, if we put this, would be times dt integrated from limits 0 to x. So what we actually do when the limits are 0 and x, where the upper limit is 0 and x, we just replace every term where there is a t with an x, and then we integrate it. But what our question asks is to eventually differentiate it 10 times. So instead of just integrating it once and differentiating it 10 times, we could just differentiate it 9 times, where instead of t, our numbers would be in terms of x. So we could take another function, which is g of x, which is equal to 1 minus 3 root x squared over 2 factorial plus 3 root x to the 4 over 4 factorial minus 3 root x to the 6 over 6 factorial, which goes on till infinity. And this, instead of differentiating 10 times, we just have to differentiate 9 times, which seems a lot as well. So what happens when you differentiate things? Let's actually just write this down till a little further. 3 root x to the 8 over 8 factorial minus 3 root x to the 10 over 10 factorial plus 3 root x to the 12 over 12 factorial minus 3 root x to the 13 over 13 factorial. Now, if we actually open this out, all the root x's would actually get squared and would just become x's. So if we write this again, we would get 1 minus 3 square x over 2 factorial plus 3 to the 4 x squared over 4 factorial minus 3 to the 6 x cubed over 6 factorial plus 3 to the 8 x4 8 factorial. minus, well, we go on, 3 to the 10 x5 over 10 factorial. Can this still be seen? Yes, it can. Plus 3 to the 12 x6 over 12 factorial minus 3 to the 14 x7 over 14 factorial, plus, as we go on, minus 3 to the 18 x9, is it? Yes, x9 over 18 factorial. And that's going to go on. So now what we do is we have to differentiate this whole series 9 times. So what really happens when you differentiate something like this? Well, you differentiate the first time, this is going to become 0 right here, while this is just going to become a constant, and it'll just remain 3 squared over 2 factorial. A 0 right here, and this is going to become a constant. And this will just be to the power of 1, this will become to the power of 2. So every power will be reduced by 1. That's when you differentiate it 1 time. So when you differentiate it 9 times, all these powers which are less than 9 will all just become 0. And only this will remain. So in the end, and this and everything after will remain. So when gx is differentiated 9 times, all of this will become a 0, will equate to a 0. So we will just have negative 3 to the 18 x9 over 18 factorial plus 3 to the 20 x 10 over 20 factorial. But what we've done here is we haven't actually differentiated x to the 9 and x to the 10. So we have to do that. So what it looks like when you differentiate it is, well, let me flip over the page. So what it looks like when you differentiate it is g to the 9 of x. Is it still on the page? Yes, it is. So what it looks like when you differentiate it is we have 3 to the 18 x9 over 18 factorial. To differentiate this 9 times, what actually happens is this term goes back down and this becomes an 8. And the 8 goes again and gets multiplied with the 9, and that becomes a 7, which happens 9 different times. So what we just eventually get is negative 3 to the 18 times 9 factorial times x over 18 factorial plus 3 to the 20 over 10 times 9 times 8 times 7, all the way till 2 this time and not till 1, well, which is still the same thing, but when it goes to 11 it'll change, and times x squared over 20 factorial, which will go on to infinity. Now what the question asks is to find the value of this function when x is equal to 0. So that, over here x does not exist, and over here x is 1, x to the plus power. Sorry, mistook that. And so when you have to look at this function's value when x is equal to 0, all these functions from after the 9th one, which are differentiated, still have x in them. So when we plug in x is equal to 0, all of these functions after this function will also equate to 0. So we will just have this function left, which doesn't even have an x. So g to the 9 of 0, which is equal to f to the 10 to the 0, is equal to negative 3 to the 18 times 9 factorial over 18 factorial, which is the answer to this question. Thank you.